Next up, we have Kelsey Hightower from Google. Kelsey will be participating in a fireside chat with two of our cloud-native Eficode experts. They'll be talking about the future of Kubernetes, and this is your chance to ask Kelsey anything Kubernetes related. And this will be facilitated by Andy Allred and Nikolai Greshold. Over to you, Kelsey.
Hello there. I'm Nikolai from Aarhus. I'm a senior consultant at Eficode. I've been with them for 4.5 years. I mainly focus on CI/CD and cloud native, and I'm a huge fan of containers and container orchestration. And it is my absolute pleasure to be here today. And I'm joined by Andy.
Yes, hi, I'm Andy Allred. I've been working in ops side for a number of decades already, more years than I care to count. And I've recently been actually running services in Kubernetes in production before I switched over to Eficode about 7 months ago, and now working as a consultant, helping other people do the same.
And I'm Kelsey Hightower. I've been around Kubernetes for a little while, and I've been in the tech industry a little longer than that. And like everyone else, I'm probably still learning something unique about Kubernetes all the time.
Thanks. It's an absolute pleasure to be here with you, Kelsey, and looking forward to get into this. So the way this will work, we've got a few questions, which we've already kind of got selected and lined up and ready to go. After that, we'll shift over to a little bit more quick fire. We got a few rapid kind of questions and see how many of those we get through. Judge that by the time, and then hopefully we'll get some questions from the audience. Please go over to the Q&A section and type your questions in there, and we'll kind of get into them. When I started working with Kubernetes, I, of course, went to Kubernetes the hard way and followed through everything. And I was like, okay, who's this Kelsey guy? And then I saw an interview with Kelsey, and he was explaining that he's not an evangelist. And the reason he's not an evangelist is because he's not saying, this is the way things work. This is the tool you need to use. He sees himself as a developer advocate. And that's because he's advocating and helping people get the job done with whatever tools are available, with whatever's good. And that interview kind of stuck with me. So in my view, I always still think of Kelsey as a developer advocate, even though I know he's actually a principal engineer now. So, but I think it's super dope that we have this opportunity to go through this and ask some questions. So first question I have is, we see a lot of changes in the CNCF and the overall cloud native community. A lot of new tools come up, for example, Crossplane, which I really like, which are basically deploying into Kubernetes and using Kubernetes as a control plane, instead of using Kubernetes as a container orchestration system. Of course, it can do both, but is this kind of a split which is happening organically, or is it planned, or how is this kind of split coming up?
Yeah, so for those unfamiliar with things like Crossplane or even Kubernetes for that matter, the one thing that separates, I think, Kubernetes from previous tools, Puppet, Chef, and Ansible, is this concept of state management, and it all plays on top of promise theory. So the idea here is that you would articulate what you want to happen as data. This is very different than some of the scripting things that people come from, where you write a script in Ruby, Python, or Bash, and then you just have it execute on the machine. Kubernetes says, hey, hold on a second, give me a piece of data, I'll store it, and then I'll converge into something that you want. So you're right. The first system was a container management system, where you say, hey, I want this container to run. I need 3 copies, this much memory and CPU, and off it goes. But if you think about how the web evolved, not everyone that's hosting a web server needs a website, right? But we can use the protocol, HTTP, under the covers to make sure that we can actually transfer information around, like a RESTful API. So I think what you're going to see in the future is this idea that Kubernetes, the protocol, which is still HTTP based, this idea of a resource, which is this Kubernetes YAML file we like to talk about a lot, and this concept of what other system can we describe this way. And so in the future, you probably won't necessarily need even a cluster in terms of nodes or orchestration management, but this idea that maybe I want Kubernetes to provision a database. In that case, you describe the database, you give it to the API server, and then its job is to have some controller that's simply watching, that knows how to understand that data and give you a database.
Yeah, that's cool. That's cool. So all the kind of control loop and control plane going through and checking state and comparing, which was absolutely critical for container orchestration, is now just applied much more widely. And that's kind of the superpower, so to speak, of Kubernetes.
If you're struggling with this concept, think about what Terraform does. Of course, there's other versions of Terraform. I think there's a hosted version that works more about the way I'm about to describe. But normally in Terraform, years ago, you would write a Terraform file, run it on your laptop, and it would only run when you execute it. But when your laptop is closed or the central server in which you invoke Terraform, nothing happens. So Kubernetes is a slightly different approach on this, is that there's always a controller 24/7 looking at that state and trying to converge. And the system feels like it's self-healing in many ways because it understands that there is no point in time where you don't want the declared state to be true, not just when you run it.
Right. All right, Nikolai.
Cool.
You had.
Yeah. So Kubernetes is awesome. It can help you in a lot of ways, but it can also be very daunting to get started with. We know that there's a bunch of managed solutions from different vendors that you can get started with easy. But how far is Kubernetes on the journey of becoming a commodity that that developers don't need to care about because it just runs in the background?
Well, we're about 8-9 years into this whole Kubernetes thing. And so when you think about it, Linux is 30 plus years old. When I first started using Linux, it was like a badge of honor to build your own Linux distro, right? You get the kernel, you pick a shell, you pick a package manager or no package manager, and then you would add things like NTP, SSH. There's so many things that goes into a Linux distribution. And we're all familiar with the popular ones, right? Red Hat, CentOS, Debian, SUSE. But we don't think about Kubernetes that way because it's so early on. But if you talk to people and you say, hey, what does your Kubernetes cluster look like? Well, if they built it themselves, they're going to say something like, there's Prometheus, I have this for logging, I have this for metrics, I'm using Vault for secrets. And you're like, wow, why is everyone coming around with so many custom, permutations of what they call Kubernetes? And the truth is, we are in the distro era. I think that began when the managed services appeared. And so this is going to be things like GKE from Google Cloud, AWS has EKS, Azure has AKS, and there's also things like OpenShift. And all of these try to make decisions at every layer. What are you going to use for networking? What do you use for storage? And of course, the load balancer for ingress. And again, all to support that initial use case around a container orchestration platform, maybe with a little bit of policy to make sure you kind of run the things that you want. So we are firmly in the distro era. So if you're in 2022 and you're still installing Kubernetes from scratch, I promise you there is a better way about doing this.
Cool. Yeah. So with this shift with people that are supposed to know about Kubernetes because someone has to run it somewhere, and all of the developers which we would like to kind of shield from being experts in Kubernetes, how do we enable the collaboration between these two? Seeing as we are at the DevOps conference, how do we prevent creating new silos or new ops teams that are then in charge of just the Kubernetes part, maybe?
Yeah, I mean, this is the DevOps conference. When we think about it, there's this shared responsibility. But look, I used to be a platform engineer or DevOps engineer or just an ops person before I was a developer. And I'll tell you one thing, I think I made a mistake back then. I never had a really good interface for what it meant to utilize the systems. It was always, give me your code, and we will run a bunch of scripts and logic, and somehow we'll end on the box. And if something broke, then we will all gather together and troubleshoot, and we would do that repeatedly for decades. If you think about what we really need in these worlds, it's not about silos, right? Silos are only bad when there's no API. When there's an API, it doesn't feel so isolated. It feels like there's a promise. It feels like there's a contract with an SLA. So really what you want, and if you've done this 15 years ago, right, before all of this Kubernetes and Docker stuff, if you had CI/CD back then, then you would have never changed most of your contract, right? It would have been check in the code, run some tests, create some artifact, and then let people describe what zones and regions do they need. And then when Kubernetes comes along, the only thing you would be changing is the last mile. You wouldn't be like, hey, let's teach everyone kubectl and let's talk about YAML files. You wouldn't be doing that. So I think it's the lack of giving developers contracts to our platforms is why we've created so much friction. And I think we went about it trying to solve the wrong problem. The goal wasn't to teach developers Docker, Vagrant, Puppet, Ansible. Those are all just means to an end. The idea was to say, how do you allow someone to declare what they need from you, and then take that information and converge it under the covers? Kubernetes just makes that easier to do.
Cool.
Wow. Yeah, of course.
You make it sound so simple.
Yeah, really.
So in a previous project, the one I mentioned in my intro, we were running for various reasons. We decided that in our use case, it was best to run all kinds of stateful services inside Kubernetes. So we had Cassandra, Redis, MariaDB, Kafka, and a few others. And we got it to work. It wasn't easy. There were a lot of considerations, a lot of trade-offs, a lot of workarounds, but it kind of felt like we're trying to take something which was never meant to be there and shove it in as a second-class citizen. I know things have evolved and gotten a little bit better with storage providers and whatnot, but how do you see that? What kind of things do we need to consider around stateful services, and is there any changes upcoming around that?
Look, I used to work in finance where the databases had petabytes of data. And the role of a DBA wasn't simply to deploy the Oracle database. There's so much more than that. There's custom file systems, there's tuning. You're not just talking about patching the Oracle binary and saying, all right, now let's deploy, we're all good here. There was constant tuning of tables, indexes, all kind of things that go into that particular job. And typically, those databases, including things like Postgres, were really never designed to be in a very hostile environment like you find in Kubernetes. IPs can change. And without a bunch of tooling, you're going to end up figuring out how to update configuration on the fly, figure out how things should be replicated. What happens when everything goes down and then it needs to come back up? Most of these databases cannot tolerate constant reshuffling around a cluster. And honestly, that's what Kubernetes wants to do by default in order to optimize resource utilization. So if you think about putting a database inside of Kubernetes, you have to understand it can only meet you. I used to say halfway, but the truth is it's probably 1/3 of the way, right? If you put it in a container, you describe what you want, what you'll find is you're going to turn off everything. Hey, do not dynamically reschedule. Do not float on any machine in the cluster. Maybe just stick to these that have enough memory, CPU, and networking to actually deal with the database. Then you're probably going to want to over provision because nobody is trying to make sure, save $5 on a smaller machine because then you're out of database capacity. I think the other thing you have to think about too is once you put a stateful set that needs to be babysat and needs to be important, the whole cluster is poison. You can't just go and update Kubernetes without considering that database now. Yeah, let's just new Kubernetes update. Let it just automatically work. I was watching blog posts, pets versus cattle. Yay. Wait, what happened to the database? It's gone. Uh-oh. Where's the data? I don't know. The nodes came up in a different zone and those persistent disks can't attach. So we're down? Why are we down? We updated Kubernetes and the database at the same time? Why did you couple those two life cycles together? So we just got to make sure that we're being pragmatic, we're being responsible, that just because Kubernetes is there, I don't think everything has to be inside of Kubernetes, let alone the same Kubernetes cluster, because I think blast radiuses and lifecycle management is still important.
Yeah. All right.
You can do it. But I'll see you on Twitter complaining about where's my data. Look, there are better tools today in 2022 than they were in 2016 and 2015 when I was issuing my initial skepticism. But I meet with customers all the time, and the first thing they open with is like, "Hey, man, we put data in Kubernetes, and we've been having problems." And I'm like, "It's not that Kubernetes is the one that's causing your problem. Let's just be clear." But Kubernetes doesn't give you things to control network I/O. if one process decides to hog all the networking on the machine, then the database is like, oh, wow, I don't have any network IO to do what I need to do. And you can't see that by just looking at the cluster or YAML files. You need to know that operationally.
Mm.
Yeah, I was reading about running a Postgres in HA and then doing it in Kubernetes. And in no part in the tutorial about running it Kubernetes was it skipping any of the stuff about just running it in HA. So it was not easier, it was just in Kubernetes as well. So yeah. If we talked about a bit about like the Kubernetes being a control plane and then Kubernetes as a container orchestrator, if you think of Kubernetes a bit like a microkernel, is it then finished, the core concepts of it, or what improvements are on the way to Kubernetes?
Yeah, I think at every level, people would love to see more improvements. Like the networking stack. Kubernetes is very opinionated in terms of one IP per pod. Some people want multiple IPs per pod. I think recently we added IPv6, so you can actually have a dual home pod that's IPv4 and IPv6. It took a long time to even get there. And so at every level of the stack, I think people would say, wow, there's a lot of resource utilization. You have fluentd for logging. You have the kubelet that takes instructions from the API server and attempts to run the workloads. You have CNI, where you need to figure out what networking stack do you want to put in place. Then you have your container runtime. So there's so many moving pieces, even at the node level, that when you think about an embedded system or edge computing use case, you don't want to have a box that just has 2 CPU and a gig or 2 of RAM just for the local data plane components. So some people would love to see that shrink. And so this is why you see distros like K3S that tend to focus on that smaller use case. And then when you get to the API surface, look, we added a lot of things to core. And I think the team did a phenomenal job saying, we're not going to turn Kubernetes into a platform. It's not going to ever be Cloud Foundry. And a lot of people may not know the history here, but there was no deployment object in Kubernetes before. There was no such thing as a volume object in Kubernetes before. Those things came from Red Hat. They added those things from the experience that they got from OpenShift. I do think it was the right idea that we brought in these higher level abstract concepts. But the truth is, Kubernetes was never going to evolve to a point where we had one way of running all application types. So this is why if you look at the API, there are things that are core, like pods are a core concept, RBAC are a core concept. But then the things that you tend to extend Kubernetes with, mission controllers, when this pod gets submitted, inspect its contents to make sure that container can run in the zone. Well, those things should be an extension, like using Gatekeeper, Open Policy Agent, to evaluate those things and then apply policy. So I think the core of Kubernetes is roughly solid. We're still learning, and this is why you start to get new APIs like Ingress v2. We learned a lot from the Ingress that there is no way, and we went down the same path that Terraform went down. I don't know if you all remember Terraform back in the day. There's just like a VM type. But we all know that a VM on AWS is big time difference than a VM on GCP. So instead of a bunch of kind of annotations and labels, we just now have better APIs that really let us describe what we're trying to do. So I think Kubernetes will continue to evolve from learning. And I think that's the best way to move forward.
Cool. Nice. Thank you for that answer.
Hi, we are Eficode, and we organize the DevOps conference. Delivering the benefits of DevOps through cloud gives the scalability, availability, and cost-effectiveness we all want. We would love to speak to you to learn how we could help you to do DevOps better in the cloud. You can find us at Eficode.com. The links are in the description. And have a great time with the DevOps conference talks.
Just a quick shout out to the audience. We do have 2 questions have come up, but I know there must be more, so please fill them in. Please get
I came for a question. I woke up early. It's 5:30 a.m. right now. And I came because of the audience question. So any question is fair game. I look forward to answering those.
Yeah. All right.
Yeah, exactly. So before we jump to the Q&A, we're just going to do like a couple of lightweight, hopefully a bit more lightweight, quick-fire questions. So to start off, just to get to know you a bit more personal, Kelsey, what did you have for dinner last night?
Oh, I made spaghetti with impossible meat. I'm vegetarian, but for some reason I still like meat. So I made some Impossible ground beef to go with my spaghetti.
Brilliant, thank you. What's the current laptop you're using?
I'm so embarrassed. On my Twitter bio, I say I'm a minimalist, and they say, well, what type of laptop do you have? I have a MacBook Pro with 64 gigs of RAM, 10 CPUs, 12 GPU. It's like, what do you need all that for? It's like, I want Vim to open real fast, and it does.
Yeah. Well, I mean, you should never go down on the tools. And my final, what's the last video game you played?
Well, the last video game I play is Magic the Gathering Arena. So I play Magic the Gathering online. I'm actually a very nerdy guy in terms of like those type of games. I like to go to like card shops where, I'm just like a regular guy and I pretend like I don't know how to play. And I enter the draft and I ask people questions like, can I do this? Do I win now? And they're like, oh my God, you totally tricked us. But yeah, Magic the Gathering is like my favorite game. I probably play at least 30 minutes a day.
Cool. Thank you.
So you put in a tweet a while ago and it became a bit of a meme, your dope rating system, dope, pretty dope, extra dope, super dope. So we would like you to rate some CNCF projects for us on your dope rating system.
And I actually saw the list and I still don't know what they all are.
Okay. So Longhorn.
Do I get a hint on what Longhorn is?
It's storage management from SUSE. It plugs in with nicely with Rancher and basically manages the storage layer.
You know what? That's dope. You know what I mean? I think people need those, especially when you're on-prem and you got random storage systems like NetApp and things like that. So look, I will give it a dope rating of just dope, because if anyone's trying to help other people solve problems, you get a dope rating.
Yep. Okay. How about Vault?
Oh, Vault is super dope. Yeah.
Cool. Cilium.
Cilium is extra dope. I think a lot of people need something in the network layer, and why not take one, especially the fact that it's based on eBPF. So I'm going to give that an extra dope.
Okay. Nats.
Nats is dope. I actually don't use it directly myself, but I do know that a lot of people prefer a messaging system that's compatible with the world of cloud native. So it's dope.
Okay. Argo CD and or Flux.
Yeah, those are super dope. I think now that people start to understand that you have a declarative workflow, you need something to manage it. Turns out configuration management is still a thing. And the fact that those projects acknowledge that and give you a workflow in order to deal with that, super dope.
Cool. Kada.
Is this the autoscaler?
Yes.
Yeah, autoscalers in general are extra dope in terms of HPA is cool until you really need to do something fancy. And then you're like, there has to be a better way. And that kind of points out the fact that a lot of things in Kubernetes are just the defaults. It's not the end. And if you need something more powerful, projects like Kada gives you the ability to do things that the defaults don't do. So extra dope.
How about Kudo?
What is Kudo?
For making operators.
Oh my goodness. You know what? I've actually seen this framework. The thing about operators is that some people, I think, are building them backwards. You probably want to build an operator that works without Kubernetes. And then you layer in this layer of glue between you and Kubernetes, because one day you might want to take your input from PubSub or HTTP. So it's definitely a dope project, but I think some people will use it in a way that will make them have to rewrite operators 500 times in the future. So think about when you build your operator, build it in a way that Kubernetes doesn't exist. And then to integrate with Kubernetes, bring your logic to one of these frameworks so that way you can integrate with Kubernetes, but don't build Kubernetes specific things, because then one day you'll probably have to rebuild it.
That was very key. Yeah, thanks. And last one, Metal LB.
Yeah, I mean, I think this is one of those things that when you get Kubernetes in your hand, you're just like, what do I do for like my networking? What do I do for load balancing? So this one is going to be on the pretty dope. It's pretty dope. I do love things like Envoy, some bias, but Metal LB is pretty dope.
Mm-hmm. Okay. And then, in your opinion, what is the super dope best CNCF project at the moment?
Y'all know it's Kubernetes. Come on now. That's the foundation for a lot of this. But if I had to pick a different project,
Please.
I think Open Policy Agent doesn't get enough credit for what it does. Once you have a system like Kubernetes and you go from infrastructure as code to infrastructure as data, the number one benefit that you'll get is this ability to build a pipeline. With code, it's hard to build pipelines because one tool can't understand the syntax and the scripting language that you're using before. But when you have data, you can do nice things like before you check in that Kubernetes manifest, you can run it through something like Open Policy Agent to verify that everything looks right. And then you can actually run another verification step in the cluster itself. So now you can take those data elements and say, hey, you can't have that much memory if you're a member of this particular team. That policy is really the thing that gives all of this stuff its superpower. So I think once people realize that when you have a data pipeline, putting policy in the mix is going to change everything in terms of how you think about managing resources effectively and securely.
All right.
Cool.
Then Nikolai had the next question.
Yes, so I know that you did a thing called Kubernetes the hard way, where you like went through really slowly all the parts it requires to set up a Kubernetes cluster. And I was wondering, what is the next thing that you're doing the hard way?
Yeah, I meant to publish it one day, and I used a little bit of it for a recent security conference, and it's called Mesh the Hard Way. And it turns out there's more moving pieces in a service mesh than in Kubernetes itself. You have things like Envoy. You need Open Policy Agent to do things like auth-z, meaning, auth-in is who you are, auth-z is what you can do. And then you need certificate management. You need Envoy in terms of a data plane. You need Istio or something like it as a control plane. There's so many moving parts to a service mesh that is more than hard. I might need to change it to like service mesh the impossible way, because I think there's so many layers required to really think about and mimic what Istio does. So that's the one that I've been working on for like 2 years. I come on and off, but it should be ready to publish at some point.
Okay.
Oh, wow. I mean, that was exactly the answer I was hoping for. I'm looking forward to that one.
Breaking news. You heard it here first. Cool. So then if it's that complicated, it's definitely something that we want to kind of abstract away and define with a few lines of YAML and let the machines do it for us in the background.
I think in the future, most people will think of service mesh as just another VPC concept. Like in the cloud, you don't really think about firewall rules as much as we used to on-prem. We tend to think about things with this label can talk to each other. And we just assume that the network fabric knows what to do with that. Well, in the world of service mesh, we can go one layer better. We can actually give things an identity. This application with this service account can do these things. And then imagine a world where you just tell the VPC that if this app with this service name or this VM with this service name wants to do something, you can now do things like rate limit. You can't call that HTTP path. We can do so many things that you can't do at L2 when you're just talking about low-level networking. But once you start to go to L7 and apply rules to it, I think that's going to be what people will consider as VPC 3.0.
Cool. And one last quick question. Do you run away screaming when you look at the CNC landscape like the rest of us do?
Yeah, so one thing about the CNCF landscape, so if you've never seen it, it was introduced years ago. And the concept behind the CNCF landscape, and rest in peace, Dan Cohn, who's I think the person who came up with this, we noticed that one powerful thing from the CNCF was that not just Kubernetes, but a whole ecosystem spawned around Kubernetes. And so what makes Kubernetes special is that we made a lot of decisions in that project. We chose to use Docker for the container runtime, which meant using OCI images and OCI registries, open container images that were based on the Docker format. We chose to use etcd for storage. We made a lot of choices. We made a choice to use Prometheus as the metrics endpoint by default. So when you look at Kubernetes, it's really a collection of choices we've made to build a distributed system for orchestrating containers. So when you go to the CNCF, you're all happy. You're probably doing your happy dance. And then you go there and it's like 10,000 projects. And it's gone from a set of decisions to more of a marketplace of ideas. And so when you look at all of those things, you're like, oh my God, like there's 3 metric tools, there's 2 policy tools, there's 50,000 load balancers. Which one do I pick? And maybe it's a good idea to foster all of these projects in one place. But I think what most people do is they just get intimidated by saying, do I really need all of this stuff? And this is why I think you're going to have the rise of the distros. You want someone to pick something from all of these categories just to give you a system that works. And look, the flexibility is welcomed, but we got to remember that if we're not careful, this whole thing can collapse under the weight of complexity. So we need to think about all of those projects in context of what you actually need.
I think we should jump over and answer some of these Q&A questions from the audience now. Just so everybody knows, I'm sorting these based on the most popular. So if you want a question to be answered, give it some likes and it'll populate it to the top, and the chances of hearing it will be higher. So top of the list right now, how do you see GitOps fitting in the future of Kubernetes?
I mean, you got to understand what like GitOps is. It's this idea that we should probably version control our configs. Git gives you a bunch of facilities for collaboration. This concept of like Git hooks, pull requests, an attempt to review. But remember that data pipeline thing I talked about. That is so important when you think about GitOps. You might have lots of tools that make sure that only the right things are committed. And then once they're committed, now you have other options. Depending on what model you go with, whether it's at the tip of a branch or you have a release where you tag something. But now what you can introduce is another pipeline that can then pull those changes in and then roll them out across multiple clusters programmatically. But again, in order for this programmatic approach to work, you need to have some logic that says, if this deployment goes to cluster A, what signals are you looking at to decide should it go to cluster B? And again, this is where a lot of the other tooling comes into play. So I think this is something the world has always needed. It's funny we call it GitOps now, but when I used to work at Puppet Labs in 2012, it was just the way you did things, right? You wrote code, you checked it in, you turned it into a module, you version the module, and then you give it to a system, and then it will converge the infrastructure. Same thing, folks. But I think the declarative nature of Kubernetes makes all of this much easier to read about because you're not trying to parse Ruby or Python code anymore.
Right. So an operational question, it's marked. Currently, when we deploy a new config map, we have to restart the pod. Will we be able to auto-reload pods if we change secrets or config maps?
So for 30 years, you've had this problem. It's just how computers work. It's how the kernel works. If you have a process, that process is launched. Usually your process will read its config on the way up. That is your call. You make a system call, file open, you process it. And then if I drop a new file in that location, your app will say, that's not my problem. You had that problem for 30 years. So Kubernetes comes around, all it does is automate this process. It says, if you put a new config map and your pod references that config map, well, the system will pull in the new config and put it in the right place and then make it available to your app. So if you want your app to automatically do this, we've debated in the Kubernetes community for a long time. Should Kubernetes really restart the pod? Which container in the pod should we restart? You can get really complicated really quickly, and maybe that's a feature we should do. But one thing you can do right now is do things like IF notify, right? It's a very common way to watch files. So when they change, because you got to remember, the reload logic for that is very hard, right? You initialize a database connection pool, you go connect to the database username and password. If mid-flight transactions are in process, you get a new database password and username, what are you going to do? You need to understand at the app level what to do with that. You may have to pause a few things, retry the connection, see if it even works, and if it doesn't, reject the config change. So there are many ways of going about this. And some people would say, Kelsey, you're right. It's too hard to reconfigure a running app. Therefore, could you just restart the whole pod and we don't have to deal with this kind of logic? And I think that's the root of that particular question, is that we don't really have great frameworks or libraries that actually know how to reload config on the fly.
Right. Okay. What's the best way to start and avoid the overwhelming amount of information out there? I guess start with learning Kubernetes.
Yeah, I don't think you can. I think what you have to understand is like where you're coming from. Take a moment to realize everything you've learned so far in order to manage the system you currently have. And if you have a roadmap of all the things you would need to do to make it secure, robust, self-healing, all of those properties that you hear about in Kubernetes, I think what you then understand is that maybe Kubernetes consolidates a lot of that learning, but it helps to understand the fundamentals around some of these properties first. So when you see them in Kubernetes, you'll say, oh, great, someone's made that decision for me. I just need to know how Kubernetes implements the fundamental. If you start in the other way, where you don't really understand the fundamentals, and then you're trying to learn the fundamentals and Kubernetes at the same time, it can feel overwhelming. So one thing I would start with is take an application that you know how to run in your existing infrastructure, and just repackage it in Kubernetes using only the parts of Kubernetes that you need and study that way. New workloads, new experience, new learning, and just be patient.
Okay. The next one, I think you just answered as well. It says, can you recommend resources how to learn to run Kubernetes in production in an on-prem data center? But I guess the answer would be pretty much what you just said.
One thing I would say here is that Kubernetes is only as good as the infrastructure it runs on top of. A lot of the advice you'll hear out here is assuming that you have a really robust IaaS system like Amazon's EC2 or Google Cloud's GCE. Without those, you may not have automatic storage system on-prem. You may not have IAM in which to fetch identity. So if you're missing all those components, just realize that your on-prem data center isn't representative of everything that Kubernetes can do. There's a relationship between Kubernetes and the infrastructure as a service layer underneath it. So just keep that in mind when you're learning that there may be differences in your own environment that don't comply with everything else.
Okay. And I just noticed that my chat window isn't updating the likes. It's not changing the order when the number changed. So I just resorted. And the number one question now here is, not sure whether I understood correctly. Have you said that one should not store a database in Kubernetes? Are you saying one has to do something else to manage the database?
So I think this is probably going to be our last question. So I'm going to be very clear here. Kubernetes is really good at stateless workloads, really great at it. Load balancers are good at managing network traffic. We don't put our load balancer on the same server for a reason. We typically move those out. So maybe one load balancer can target multiple clusters. It's okay. That will totally work. There are other options for things like stateful services. Like let's say you need a CDN to distribute images and videos. Put that in the CDN. You do not have to put it on an FTP server in Kubernetes. You could evolve. And so when it comes to a database, there's managed services. If you're in the cloud, it's okay to pair a Kubernetes offering with the managed database offering. And then it's okay to run on a VM that is hyper-tuned just for your database. And look, if you just really got to put your database in Kubernetes, you can, but it doesn't mean all those other things aren't a good idea.
All right. That's all the time we have, but I just want to say thanks, Kelsey. It's been an absolute pleasure to talk with you and get these topics brought up. Definitely, I'm going to take a look into OPA some more because that looks really nice. And I really love the idea how you explained that the API promises, and if we think about that and design kind of outside of Kubernetes and then just how to map into Kubernetes, we're not going to end up rewriting many times in the future. That was really, really key. So thanks a lot. And I guess we'll go back to the host soon.
Thank you.
Thank you. It was wonderful to listen to the three of you folks talking. I was equally excited as you were listening to that, though I must admit I'm still a little bit confused about Kubernetes, but on a higher level.
Totally clear for me.
But not to worry. I think Kubernetes can provide this confusion orchestration system or something like that. I'll read my notes.
Okay.